Mr. Azasi, are you ready?
Yes. Hey students, I'm going to share my screen with you guys because I need to show you a PowerPoint about today's lesson. Okay, so let me share my screen, and this way I'll go straight to the PowerPoint. Do you guys see the PowerPoint?
Yes, sir.
Okay. Okay, let me start. Okay, students, today I'm going to cover why it's part of 0324 and 1324. But mostly for 0324, it covers, I think, evaluating exponential functions. Okay, which we're going to do a little bit today, but mostly we're going to focus on the 1324 class. Okay, which is solving exponential and logarithmic equations. There's only 3 topics that I'm going to cover today, okay? I have about 10 slides to show you with examples and the things that you guys need to know before we get started, okay? So for example, today's topic that we're going to cover are solving exponential equations by using the same base rules. And for that topic, you're going to have to know what we learned in the past, okay? And I have there the material that you should know, okay? So we can actually solve those. The second one, we're going to be solving exponential equations with different bases. And lastly, we're going to be solving logarithmic equations by using logarithmic properties. Okay. Okay, first, solving exponential equations. To solve an exponential equation without a calculator, you need to know previous topics such as, okay, guys, we need to know the perfect squares. Remember when I did the workshop on factoring, right? Where you have to know the perfect squares. Well, here they go again. We have to know these, and also perfect cubes. At least know all the way to the 6 to the 3rd power. But the more that you know, the better it is for you. Okay. Also for the square roots, the more that you know, the better for you. And also 4th roots. For example, I just did all the way to 5 to the 4th power. But again, the more that you know, the better it is for you. And also, it's crucial to know exponential expressions. And that I did last week. Remember the a to the m, that's the expression, where the a is called the base and m is the exponent. Okay, that's going to be crucial for today's lesson also. And also, you have to know the exponent power rule. That's what I went over last week. And that's the exponent power rule. What else do we need to know? You need to know how to solve one variable equations. Example, that's like a one variable equation. We have to solve for x. Okay, now, why am I doing all this? Because I like to start off with things that you guys should know. Because at times, some of the students that they take some math classes, they're not up to par with the material. So for example, if you struggle with any one of these topics here, you know what I'm saying, you're going to struggle with today's lesson. So that way, it's like a self-check. If you know all these, like the perfect squares, perfect cubes, perfect 4th roots, and so forth, you're going to be okay. Okay, this way you know exactly what you need to to work on. Okay, now this is solving exponential equations, and here's like a rule or like a property. Okay, it says let a be a positive real number, where a cannot equal to 1. So if a to the u equals to a to the v, then u equals to v. So these guys, the a's are called the bases. So for you to apply this property, you have to have the same base. Okay. Let's do an example here. Example 1. If we notice, you see the bases are the same, right? 3 and 3. Which means same base, we can apply the rule. So if you have the same base, then the exponents must equal to each other. You see, so x must equal to 5 for that to be true. Okay, very, very, very basic. But at times, they don't have the same base. So we have to do something with to get it with the same base to apply this property here. Example number 2. If we notice, the base here is 8 and the base here is 2 to the 5th power. So they're different bases, right? So that means not the same base, so we have to do something to them. We have to convert the 8 into the base 2 into a certain power, which is 3, and that we got it from the perfect cubes that I told you that we need to know. So in other words, 8 is equal to 2 cubed. Why do we need a 2? Because this way you have the same base. You see, guys, same base. Now we can apply one of the properties that we learned last week, which is apply the exponential property or the rule. Remember the exponential rule? When you have a power raised to a power, you multiply the powers. So that's what I applied. Now we got the same base now, right? Same base. So now that means that we can apply the rule. You see, same base, apply the rule. So when you have the same base, you let the exponents equal to each other, and then it's just solving a one variable equation. We divide both sides by 3. So x equals to 5 over 3. Okay, now, the good thing about all these students is that you can always check the work. Okay, you don't have to check, I mean, you don't have to check your work if you don't want to, but it's always good to check your work to make sure that the answer is right. Okay, until at least you know how to work them. So how do we check them? You can always check your work, right? So here we go. We have 8x, right? That was the original here, guys. This one here. 8x equals to 2 to the 5th power. So we got that x was 5 over 3, correct? So now we're going to plug in 5 over 3 for the x's. So here you can actually put it in the calculator, okay? But later, but after I'm done with this PowerPoint, I'm going to show you how to do it by hand. And you do it by hand by one of the rules that we didn't get. I mean, last week, the exponential expression when you put it from exponential to a radical and back and forth. So I'm going to show you how to do that after the PowerPoint. But in this case, you can put in the calculator, just put 8 to the power of 5 over 3, and you're going to be getting, you see, plug in the calculator, you're going to be getting, or without a calculator if possible, right? So you're going to get in 32. This is equal to 32, so 32 equals 32, so I know it's correct. Okay, and again, I'm going to show you this part here, how to do it by hand, okay? Okay, now, solving exponential equations continue. Again, example 3. And we notice the bases are not the same. So we have to make them the same. How do we start here? We always get the smaller base, right? And we square it. See if it's give me 27. And if it doesn't give me 27, that means that we have to simplify both of these bases to lower bases. Okay? So for example, 9 squared equals to 81, which does not equal to 87. I mean to 27. So in other words, I have to change both bases, the 9 and the 27. Find common bases between 9 and 27. And here's where 9 is equal to 3 squared, right? And 27 equals to 3 cubed. So now I'm going to rewrite these two expressions on either side, or the equations, which is two expressions, one on each side. I'm going to rewrite them with the bases over here. So 9 was 3 squared. And 27 was 3 cubed. Now I'm going to apply the power rule. Apply the exponent power rule, right? When you have power to a power, you multiply the powers. So 2 times x is 2x. Now, right, now we have the same basis. Same base, apply the rule. So the rule stated, if you have the same basis, right, same base, then you let the exponents equal to each other. And then just divide both sides by 2. So x equals to 3 over 2. Now again, you can always check your solution. So let's check it again. So x was 3 over 2, so I'm going to plug in what 3 over 2, right? So where the x is. So 3 over 2 equals 27, and again, if you put that in the calculator, it gives you 27. But again, after this PowerPoint, I will show you how to do it by hand. Okay, because there's some instructors that they limit the calculator use. Okay, so it depends what instructions you get, but some instructors want to see all the work, especially something like this that you can do everything by hand. So that's why I'm going to show you how to do it by hand, okay? But I will show you after this PowerPoint. You see, guys, so it checks, so I know that's a solution. Okay, now let's do let's see here another example. You see, they get a little bit more challenging, right, as we go along. So again, not the same base, right? So here we go. Does 4 squared give me 32? No, 4 squared is 16. Does not give me 32. You see, we're not at 32 yet. So let's try 4 cubed. 4 cubed equals to 64, which is not 32, which means I have to simplify both bases to make it the same. Okay. Find common base between 4 and 32. So 4 is 2 squared, and 32 is 2 to the 5th power. Okay. So now I'm going to rewrite these into the same basis with a base being 2. So 4 is 2 squared, and 32 is 2 to the 5th power. Okay, now we apply the exponent power rule, which means when you have the same, right? So it means when you have a power to a power, we multiply the powers. Now we can apply the rule. That means that same basis, the exponents, you set them equal to each other. So here we're going to do the distributive property, which means I'm going to multiply 2 times x and 2 times -1, which gives me 2x minus 2. And then just a simple one variable equation. You add 2 to both sides, right? So we have 2 here and 2 here, right? They'll cancel, so we have 7. So then we divide both sides by 2, which is 7 over 2. And again, you can always check your solution. Here, some of you guys might think, well, this is very basic. This is it's too many steps to show and to actually let the reader know. I mean, let the viewer know what we're doing. That's because the way I do things or the way I teach, I don't like nobody to be left behind. So, if, for example, if you already know some of this stuff, well, it's more power to you. But I don't want nobody to be left behind. I want somebody to come in with little math knowledge, and then for them to be able to actually, follow. And that's how I do all my classes. I don't want nobody to be left behind. So here, guys, so I'm going to plug in, right? So here's my equation again. So I'm going to plug in the 7 over 2 where the x is right here. So 7/2 minus 2 will give us 5 over 2. And again, if you put this in the calculator, 4 to the power of 5 over 2 is going to give you 32. So it checks. So that's a correct answer. Are you guys okay up to this point? Does anybody have any questions?
There's no questions so far. Does anyone have any questions? If you have a question, feel free to raise your hand and turn on your mic.
Yes, because this way you guys can get instant clarification right now before I move on. Okay? Patricia, just give me pause it, okay?
Yes, I'll keep an eye on it.
Thank you. Okay, let's continue then. So now, guys, we're going to be solving logarithmic equations now.
Oh, we have a question, Mr. Azasi.
Yes.
Want to turn on your mic and let him ask your question? Oh, I'm sorry. I thought someone had a question because I heard a mic come on. I'm sorry, Mr. Azasi. Please proceed.
Okay. Okay, again, okay, let me go back a little bit, okay, because let me see here. Here we're going to be solving logarithmic equations. Also, there's some properties that you guys went over, I think, in your course in 1324 last week, which was, I think, 4.3. So we're going to apply these when you solve these logarithmic equations. To solve logarithmic and exponential equations, you need to know previous properties such as these are the logs. For example, if you have this here is called condensed, they're together, and this is called expanded. So when you multiply, right, when you have the log base a to xy, right, when you multiply them here, you separate them and you add them. When you're dividing, you separate them and you subtract them. And this is called the power rule. If you notice, the R goes to the front, and this is very crucial for today's lesson because when you're solving something that you need to solve for the exponent, right? Say the exponent is x, and you're trying to solve for that one, you always take the log or the ln. I prefer the ln. Okay, this is called the product rule, quotient rule, and power rule. These are the logarithms, and these are the natural logarithms. I prefer to use these right here because these you'll be using when you have the base e, because the ln and the base e, they cancel each other, is equal to 1, and you'll be seeing that when you do word problems, and also when you do the mathematic. I think is next chapter where it's all about finances. I mean, it's all about money, and you have to be solving for the exponent, like for time or for the interest rate. Okay, which hopefully I'll do another PowerPoint for next week for those topics. Okay, so again, you see these are the same, right? But now the ln doesn't have a base, right? It's just ln of xy equals to ln of x plus ln of y. These are very similar. Okay. Okay, now why are these crucial to know? Because hey, remember this example that we did, and we did it. Say for example, this one here can be done without a calculator, and I did the example earlier. That was example number 3. You guys can go back afterwards and look at the example and look how easy you can do it by applying one of the rules here. Okay, but I repeat, there's some instructors, including myself, that I like to if no calculator is required, I want you guys to know it by hand. And now, say for example, for the sake that you forgot how to work it by hand, there's always like an alternative, and this is the alternative. Remember, the answer was x equals to 3/2, right? Because if we put here 3/2, it's going to give me 27. So now, how can we do this problem another way? Solve by using the power property of natural log. So we're going to apply this property here. Okay, if you have 9 to the power x equals 27. So what do we do here? We're going to bring down the exponent, right? Because we're solving for x. We want to bring it down. So every time you want to bring an exponent down, because it's a variable and that's the missing variable that you're looking for, you always take the ln on both sides. And that's legal in math, as long as what you do on one side, you do to the other side. Okay, so we just bring it down how it is. And we take the ln on the left side. So we must also take the ln on the right side. Hey guys, let me share something with you guys here. When I was doing the master's program, the instructor would say, if you take something to the left of the number here, you also have to take it to the left on the right side on both sides. And I never understood that. Why was he saying that? And now when I became to when I started teaching and doing extra research and stuff, this is the reason why. Because you cannot put the ln in the front here and put it over here on this side because it doesn't make sense. And the ln of a number, guys, is a number. It's all together. Do not get it confused that the ln and the 27 are separate. It's one complete. It's a value. For example, if you plug in the ln of 27 in the calculator, it's going to give you an answer. It's going to give you a value. Okay, so these are together, like a number. Okay. So now, we're going to use the power property, right? The exponent, right? The exponent, if you have ln of a variable to the r power, the exponent goes to the front, right? And this is legal because we took the ln to both sides. So by rule, the exponent, the x, comes to the front. And now, all we do is solve for x, divide both sides by ln of 9. So there's my answer, guys. And all you do is put it in the calculator, and you get the result, which is right here on the bottom, which is 1.5. Right? You see this in the bottom, 1.5, which is also equal to 3/2. You see that was the same answer. So this is another way to do it. And when this is very useful, this rule here is when the exponent, when the bases you cannot get the same base because they don't have a match. Okay, like the next example that I'm going to do. Okay, now here, very important. This is what I just mentioned. The ln of a number, right, is an actual value. Cannot separate them. Why did I put here like a number sign? Because I was in a space here. I should have put here the ln of x, right, and x is a real number. But at times, when I use math language for this course, people get confused. Like for example, if I would have put here like an x, right, like the ln of x, and I would have said x is a real number. At times, the math notation is good to know, but at times it kind of some of the students get confused because of the notation. Okay, so make sure that you know the notation, but I just put a number there, and like I said earlier, I don't want nobody to fall behind. Okay, so everything is very clear here. Okay, and again, very important, the ln of a number is an actual value. Cannot separate them. For example, the ln of 27 is a number. The ln of 9 is a number. You cannot cancel the ln's like that, guys. Like, that's how you're going to do that. You cannot do that. Okay? So you have to put in the calculator the ln of 27 divided by the ln of 9 to give you the correct answer. You guys okay with that? Any questions?
No questions so far.
Okay. Okay, now, let's see here. Let u and r are real numbers. With u positive, then if you have the ln of u to the r equals to r ln of u, right? This is a property that we just used, right? The power from, this was the natural log power property. Okay, and here's an example where this is very useful. You see, there's no way I can get the same base with 5 and 8. So here, what we do here, you see not the same base and cannot get them with the same base. So we want to bring down the exponent, and how do we do that? We take the ln of both sides. And again, what we did in the previous example, right? So we bring the problem down. And why do I put some space here? Because I'm going to put the ln on the left and the ln on the left of both sides. So we take the ln, we take the ln. Now we can apply the rule, right? This property here. Use the property, the power property, where the exponent goes to the front, and there it is. Right, so the exponent goes to the front. Now we have x ln of 5 equals to ln of 8, and I repeat, ln of 5 is a number, is a value, and so is ln of 8. So then we're going to divide both sides by ln of 5. So x equals to ln of 8 divided by ln of 5, and this, use the calculator, right, because it's real hard to do it by hand. I mean, it's really impossible to do it by hand. So approximate, it'll be 1.2920. And most of the times on your homework, they're going to want you to round off to 4 places with the ln's and also the logarithms. So I rounded out to 4 places. So again, you can always check your work or your answers, right? So we have 5 to the x equals 8. Remember, I'm going to plug this in where the x is. There it is. So it'll be 5 to the 1.2920. And that's what it gives me, guys. It will never give you the exact answer. Why is that? Because we rounded off, right? Because we rounded off to 4 digits, right? So that's why it will always be real close to the actual number, always. Okay, so that means that it's correct. That's where we can check our work. Okay, now solving logarithmic equations continues. Now here it's going to be very similar to the basis, right? So we have, but first of all, let u, v, and a be positive real numbers. Which means, guys, this cannot be negative, and this cannot be negative, and the base cannot be negative. They all have to be more than 1, okay? I think also it cannot be 0 either, because if you put in the calculator the log of 0, it will also be undefined, so it has to be more than 0, okay? So here, guys, if we have the log of a, so here, if you have the same log of a, same log and same basis, then the u must equal to b. For example, example 6. I believe this example, I got it from the book. I got it from the Math 1324 book. I think it's example number 1 for that section. So here, right, in order for you to apply this rule here, you have to have a single log on both sides, or condensed. To apply the rule, single log must be on both sides. You see here is okay, the left side's okay, but the right side is not okay. You have to make him into 1. And here's where we use the properties that I showed earlier, right? And remember, guys, this is the opposite when you subtract, right? If it's subtraction, that means that you're going to be dividing these. You're going to put the log, right? You're going to put the log, and it'll be x plus 3 divided by x minus 1. This is expanded form, and this is condensed form. So you have to condense it under a single log. Now, right, single log on both sides. So now you can apply the property here. So if you have the same log, right, with the same base, so then the value here, the x, must equal to x plus 3 divided by x minus 1. Okay? That's according to this property here. So what do we do now? We just solve for x. So here we cross multiply, right? Because this is like a 1 here. So remember that like when you have two ratios that are the same, right? We multiply these and must equal to, we multiply these right here. But this is like an invisible 1 here. So we're gonna have x times x minus 1 equals to x plus 3. If you guys don't want to do the cross multiplication because that kind of confuses you, then multiply both sides by x minus 1, right? Because you don't want the denominator to be there. So you multiply this side by x minus 1, right? The x minus 1 will cancel. And if I multiply x minus 1 times x, it's going to give me what I have here. Now I use the distributive property, right? Which means x times x is x squared. X times negative x is x times negative 1 is negative x, and we bring down the x plus 3. So here we have to set the equation equal to 0 on the right side. So these two terms must go to the left side. How do we do it? By subtracting negative x minus 3, right? So that way they'll cancel here on this side, so it'll give me a 0. But we have to add them over here on this side. So it gives me x squared minus 2x minus 3. And remember when I did the workshop on factoring, guys, here it is again. You need to know how to factor. Factoring is very crucial for math. Okay, so again here, you can either factor or use a quadratic formula, but it's easier to factor. If you factor, remember the rules. If this is negative, right? Remember the rules from last time. If that's negative, it means the signs will be different. And this, and you always break it down. So that's why it's going to be negative and a positive. And then we get the factors at 3, right? And it's going to be the difference that will give me negative 2x. So the biggest number goes here. So we have x minus 3 and x plus 1. And again, I'm referring to the workshop that I did about 2 or 3 weeks ago in factoring. You can go back to that if you struggle how to factor. Go back to that PowerPoint. Now here is going to apply set binomial equals to 0. Here in math is called use the zero property theorem. Okay, but you guys are not there yet. That's why I don't want to state the theorem there. Okay, just set each binomial equal to 0. So for example, I'm going to set this one equal to 0. It's here on the bottom. X minus 3 equals 0, or x plus 1 equals 0. And just solve for x. It's in the bottom here, guys. X equals to 3 or x equals to negative 1. Okay, so these are my two answers. Are you guys okay up to this point? Can I proceed?
There seems to be no questions, Mr. Azasi.
Okay. Maybe this is like straightforward now. That's what I'm thinking. That maybe it's like. Oh, and here, guys. Okay, I'm going to check my solutions. How do we check my solutions? Okay, I'm going to go to the next slide. So check both solutions. To check both solutions, right? It's going to be x equals to 3 and x equals to negative 1. So this is the original logarithmic equation. So I'm going to plug in negative 1 and here for the x values, and then I'm going to plug in 3. Okay, so here we go. Here's my equation. So I'm going to plug in negative 1. I'm going to plug in negative 1 there for the x, negative 1 here for this x, and negative 1 here for this x. Hey guys, if you happen to have a calculator with you right now, or right there at your disposal, just put in log of negative 1, see what it gives you. Does somebody have a calculator with them right now? Okay, I have one here. Gazelle, could you plug that in the calculator? Just put the log of negative 1, see what it gives you. Right, it means it's not a real number. Okay, Gazelle, now that you're there, Gazelle, put the log of 0, see what it gives you. Because this is what I tell my students when I'm teaching this topic here. Enter log of negative 1 in the calculator, see what it gives you, and then I tell them enter log of 0. So enter log of 0, Gazelle, what does it give you? Error again, right? Let me see here, let me try myself, log of 0. It's going to give you, again, error, right? Plug in log of 0.00001. See what it gives you. Something real close to 1. Log of 0.0001. gives you a number, right? So it means, guys, that the domain of a log has to be more than 0. It cannot be equal to 0. So in other words, this is what I tell my students. Okay, so I mean, I don't explain it here on this PowerPoint, but this is what I tell them. For example, here, you take this one out, the x here, right? Let me see if I can write here. No, I don't want to write it. Right, so you let x be more than or equal to 0, which means your values have to be more than or equal to 0. I mean, for this one here. If you plug this one here x can be negative 2, right? At the least, because it's going to give me a positive 1. And here, I can have no negatives. So the domain, really, I tell my students to always get each, expression here, each term, the log, and let it be more than or equal to 0. So whatever you get, that's not that's not a domain, that answer cannot be that. So if I would have done that at the beginning, I would have known that negative 1 could not be the answer. Okay.
Mr. Azasi, we have a question.
Yes.
We're asking, so you can only take the positive values in for x?
Yes, yeah, that can be true to a certain extent. For example, if you had something like the log of say the log of x x minus 3, right? X minus 3. If you plug in 1, wouldn't it give me negative 2? So that's correct, only partial correct. Okay, but you always plug them in. When you, which let me show you. Say for example, right? Say for example here. Say the answer was 1, right? So the 1 is okay here, the 1 is okay here, but the 1, if I put 1 here, what's 1 minus 1? It's going to be 0. And you cannot have the log of 0. So it's always wise to actually plug in the value to the log, right? For the value for the log is. And this way, if it's negative, it cannot be the answer. Okay? But to answer your question again, that is true only to a certain extent. Okay? Because at times you can get positive values and it still be undefined. If you want, I'll do this for you. Okay? I'm gonna show you that after I do the PowerPoint. Let me write it on my board here before I forget, so I can show you what I'm talking about. Okay? Let me put it here on my board. Let's see, log. Okay, I just put it on the board there, so when I'm finished, I can actually show you examples. Okay. Okay, now, okay, let's continue here. So that way, this is not defined, right? So that means that negative 1 is not a solution. So now let's try the 3. So when x equals 3, right? We do the same thing. We're going to plug in 3, right? We're going to plug in 3 for every x. We plug it in there. We plug it in here for the x, and we plug it in here. So this will give us log of base 3. This will be 6 minus log of 2. Now here, you can plug this in the calculator if you want. Both sides, plug them in there. But you can also do this by hand, right? You can use a calculator, which if you plug in log of 3, it's going to give you 0.4771, and I round it off to 4 decimal places. If you put log of 6 minus log of 2, it's going to give you a 0.4771. Hey guys, if you notice, what's my base here? What's a base? Remember last week, if there's no base, what is it? Does anybody know? Yes, very good, base 10, right? So in most calculators, it only uses base 10. There's some new ones, they're more advanced that you can actually put the base. But in most calculators, you cannot use nothing else but base 10. Okay? Or we can do it by hand. Use the quotient, right? We use the quotient property. Remember the quotient property? If you have the log with the same basis, right? And it's a minus, can we put them together and condense it into a single log? Wouldn't it give us log of 6 divided by 2, which will give us log of 3 equals log of 3. Or you can do it by using some of the properties. But most students prefer just to plug into the calculator, which you can. So this is a solution because they're both equal to each other. Okay, now I believe this will be the last property here, or the last rule. Again, if A and U are positive real numbers, with A is not equal to 1, then A, right? A is a base, and log of base A of U is my exponent, is equal to U, which means if this base here and this base here on the log, if it's the same, this becomes 1, or it cancels, it becomes 1, and you just bring down the U. So this is very crucial for what you're going to be doing for the next example here. Okay, for example, example number 7 says solve log of base 3 of 6x minus 2 equals 2. Okay. So again, we need to cancel the log of base 3. We don't want this here, right? Because we're going to take that out because we're solving for x. It's trying to get to the x, right? So, but you have to follow the math procedures, legal math procedures, not whatever you want to do. So here we need to cancel this right here. So how do we do it? Okay, so check this out. So here we're going to apply this rule here. Okay, this is what we're going to know. We're going to let the expression on both sides of the equal sign be the exponent. So this is going to be my exponent because I'm going to apply the rule here. And the base of the logarithm be your base. So this will be my base. So that means I put a 3 there. And if this was a 4, if it was base 4, then it'll be a 4 here. If it was a 9, then this will be a 9 here. But when you do it to this side, you also do it to the other side. So again, this is legal than math because this, the expression, the equation at the beginning, that's right. What I did to the left side, I also did to the right side. You can do that. Okay, now we can apply the rule, right? The rule here. So that means that we have 3 log of 3, right? So this cancels or is equal to 1. And 1 times this will just give me the 6x minus 2. Now we have to simplify, right? Simplify means what's 3 squared? 3 squared is 9. Now we're solving a one variable equation. We can add 2 to both sides. So plus 2, so it cancels here, so it gives me 11. And then we're going to divide both sides by 6. So this is my answer. Why did I put it like in purple? Because I'm going to plug it in purple here while I check my work. Okay, so I'm going to check my work. And I had to get creative here because I don't want to go to the next slide. So I came up with this right here. So here's where I'm going to check my work. Right, so this is my original. The log of base 3 of 6x minus 2 equals 2. So here's where I'm going to plug in the 11 over 6, which was in purple here. The answer, I plug it in here. So you notice, if you multiply 6 times 11 over 6, the 6 cancels, right? So I'm left with log of base 3 of 11 minus 2, which is log of base 9 equals 2. And this answer is equal to 2 because, remember the rule, guys, that we did last week? To what power do we raise the 3 to give me 9? So the answer is 2. And so it checks out. Also, there's also a rule called the change of base. For example, I'm also going to show you that when I'm done with a PowerPoint. Let me put it here. Show you the change of base. Change of base. Okay, now let me see what's next. I believe that's it, guys. Well, that's it. Let me get back to the. Are you guys okay? Any questions?
Sorry. Hi.
Hi.
I had an exercise that I have like a lot of questions on, but
Okay.
it's related to this topic, but it's to solve for C. So it says there are logarithms, but it says to solve for C.
Okay, right now, if you want, we can do it on the board. Right now, when nobody has any questions, we see if we can work it out for you. Yeah?
Yeah, thank you.
Oh, you're welcome. Anybody else? Are you guys okay? Okay, let me go back to let me go back here. Let me stop sharing here. Oh, here we go. Okay, now, so question, hey guys, you guys see my eraser board?
Yes, sir.
Okay, now let me show you this real quick, okay? Hi guys, my name is Mr. Isasi, right? So check this out. Let me do this one first. Remember we had 8 we had 8 to the 5 over 3. And I show you that you plug in the calculator, I mean, it's going to give you the answer. Remember that? How do you do it by hand? We're going to apply this rule here. If you have a to the m over n is equal to the nth root of a to the m. But I don't like to use this one. Why? Because this one can get a little bit complicated, okay? Let me show you what I mean by that. By applying this rule here, this is my radical, or my radicand. This is my index, and this is my exponent. Well, check this out, guys. If you put a to the 5th power, what's my answer? I don't even know, right? So a to the 5th power is going to give you something real crazy. A to the 5th power gives me like 32,768. So if you do it this way, it gives you 32,000. Let me erase this. Hold on. 32,768. This means what's the cube root of 32,768? Isn't it kind of hard? I mean, without a calculator? That's why I don't like to use this rule here. That's why I like to use this instead. Instead of this one, I like to use this one here. The nth root of a, everything to the n power. Okay, I'm going to apply this one here. Okay, so I'm going to apply this rule here instead. So we have, okay, this is what I'm going to apply again. Because this way it makes my work much easier. Okay, here we go. Let me do this one here. So we have 8 to the 5 over 3 is equal to the cube root of 8, right? And by applying this rule means that the 5 goes on the outside, right? Same rules. But this one is much easier to work without the calculator. So what's the cube root of 8? It's going to be 2, right? And remember I told you that you have to know the perfect cubes and also to the perfect cubes and all that stuff. So that's why this way it comes in handy. So what's 2 to the 5th power? The answer is 32. You see, by using this rule or this one here instead of this one, this will make your work much easier without the calculator. Because this will be kind of real hard to get the answer, the cube root of 32,768. So it's better to use this rule here. Okay, now, let me see here. Okay, now, remember the other question that I had. Hey guys, are you guys okay with this explanation here?
Anyone got any questions? There seems to be no questions, Mr. Azasi.
You know, let me show you what one said about the positive, right? Will always be positive. Let me show you something when it's not. Okay, now, let's pretend that you have something like this, okay? But I don't know if it's, if you had something like this. Log of x equals to log of x minus 7 plus log of x plus 3. Hey guys, this is what I mean. That, I mean, to answer the question, does the log always have to be a positive number? Yes, but after you simplify these. For example, say we had, for example, this one here, right? X has to be more than 0, right? For that to be correct. This one here, x minus 7 has to be more than 0. And this is finding the domain of the logarithmics. So here, guys, x must be more than positive 7. Because if I have something less than positive 7, it will be undefined, okay? Or not a real number. And for this one here, x plus 3, right? You always let it be more than 0, so then minus 3 minus 3. So x must be more than negative 3. So what's my domain? My domain is always the biggest number, guys. So this takes priority. So all your answers must be more than 7, or else it's not defined. And at times there's some solutions that they don't have an answer because it's undefined. Because all the logs didn't meet their criteria. Because if you plug back the answer, for example, if I plug the answer here, right? Say that I plug in a 6. 6 minus 7 is negative 1, so it won't work. What if I plug in a 7? 7 minus 7 is 0, and we cannot get also the log of 0 will also be undefined. Okay. Now let's see what other question had. Okay, the other question was from this young girl, right? That she wanted to solve a problem. Right? Let me see. We have time here. So you want me to do it for you, or you want to get one of the tutors?
You.
What's that? Okay, one more thing. Let me show you the change of base. Okay? Remember what I said that so you have something like log of base 3 of 25. This we're gonna apply the change of base to get the answer. For example, this is called my change of base. Change of base. If you have log of base 8 to the x, right? This can be any base, even 10. So to apply this formula is equal to log. Now it becomes base 10 of x over log of base 10 of a. So for example, on this one here, right? To do this one here, right? For the change of base. This will, because this cannot be put in the calculator the way it is, because most calculators only have base 10. So the answer for this one will be log, to simplify, it will be log of base 10 of 25 over log of base 10 of 3. And you put that in the calculator, guys, to get your answer. Okay. So any more questions, or do you want me to go over anything? Does anybody want me to do something here on the board for them? If yes, just give me the equation, or I'll get one of the tutors.
They're asking if you could share the presentation with them again.
Of course.
You want to put your email in the chat for them so they can email you?
Yes, let me put the email here. There we go. You send me an email and I continue with the PowerPoint like I did last week. I think last week 3 students actually reached out to me for the PowerPoint, and I was more than happy to send it to them.
Well, if there's no further questions, we have some tutors today standing by. If anyone would like to work in a group with one of our tutors, they're absolutely amazing. Mr. Azasi, we'd like to thank you very much for your wonderful presentation today. There was a sign-in link put into the chat earlier. Make sure y'all sign in, please. A lot of the math instructors are looking at that sign-in sheet, so it's very important. We hope that you'll join us again next week. Next week we have, let me take a look. For our Sunday number, for our Happy Math Hour, we have finding zeros of polynomial functions for Math 1314, and then for 1324, we'll be doing simple, compound, and annuities, which is a tough subject in Math 1324. So be sure to come and visit us next week. Thank you, Mr. Azasi.
Oh, you're welcome. You're welcome. Thank you. Thank you, students.